Okay, so section 5.4 is over what's called the sum and difference formulas. And from the unit circle, which yes, you still need to know, we don't memorize all 360 degrees and 360 different radians. We don't memorize all of those points around the unit circle because that would just be insane to memorize that much stuff. But what we do memorize is at 0, and then in quadrant 1, 30, 45, 60. Those are all spots that we're supposed to know the point of, and therefore know the sine and cosine of each of those. And then with sine and cosine, we can find any of them. And then in quadrant 2, we know 120, 135, and 150. Let's see, 210, 225, 240 are the ones from quadrant 3 we're supposed to recognize and be able to deal with quickly. And then of course quadrant 4, 300, 315, 330, and then we get back to where we started. 360 is coterminal to 0, so then they just start repeating themselves. So that's a good handful to memorize. But there's some patterns in there, so it's not really like you're memorizing quite that many points. But those are the ones that you're supposed to recognize up to this point. Well, the point of this section is to say, well, maybe we want to know what is the cosine of 105 degrees. 105 is not one of these spots we memorize on the unit circle. If we only needed an estimate, we could type it in our calculator. But just knowing the unit circle and knowing a couple formulas, you can actually figure out the exact value of cosine of 105. So these are the formulas that you need to jot down for your practice. The sum and difference for sine, sum and difference for cosine, and sum and difference for tangent. I'm 99% sure you won't have to memorize these for the quiz. So this is just saying, like, if you added 2 angles or subtracted 2 angles. We're going to call the first angle U and the second angle V, just for simplicity. So the sine of some angle plus some angle is going to be the sine of the first angle times the cosine of that second angle plus the sine of the second times the cosine of the first. So as long as we can split the angle up into 2 angles we know, so like 105 could be split up into 60 plus 45, and we know 60 and we know 45, it allows us to break it up into pieces that we can use. Now, the only difference with the difference one is it has a minus sign in the middle. Otherwise, the formula is exactly the same. So if you look in a textbook, or when we give you these formulas on the quiz, it's probably going to be condensed into one statement. It's going to look like this. If the plus is on top, that corresponds to this on top. And if it's a minus, since it's on bottom, you would use this sign, which is a minus. So if you understand, if this is a plus, that's a plus, and that's a minus, that's a minus, you can really write that in one statement.
Is sine U cosine V?
Yeah, cosine V, yes. Okay, for the cosine ones, the cosine stuff gets grouped together. So you would take the cosine of the first angle times the cosine of the second angle, and then you use the opposite sign of whatever's here. If it's a plus, it's actually a minus here. And then it groups the sine stuff together. And then luckily, if you just change this from a sum of 2 angles to difference of 2 angles, you just change this middle sign. So usually if you look in a textbook, You Google search the formula, whatever, they're probably going to put it into one statement. So let's make sure that we understand what that looks like. Sometimes it's a plus, sometimes it's a minus, but it's always cosine of the first times cosine of the second angle times sine of the first times sine of the second. And cosine uses the opposite signs. So if you're adding here, this is a minus, and if you're subtracting here, that's a plus. So again, this one statement is just a condensed way to write both of those. All right, and then tangent, the only other one we look at. Technically, if you wanted to be able to do sum or difference of secant, cosecant, or cotangent, you could use one of these and then just do the reciprocal. So it's not too bad. So tangent, you would do tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first times tangent of the second. If it's a difference, so you're subtracting the angles instead, then this plus becomes a minus, and that minus becomes a plus. So if you really want to condense those into a single statement, which again, you don't have to do, but you probably should be able to read it. It would look like this. The only thing that changes are these signs. If you're adding, this one's a plus and that one's a minus. And if you're subtracting, this one's a minus and that one's a plus. So just think about the location. If it's a plus, it's on top, so you would use the signs that are on top. If it's subtracting, it's on bottom, then you would use the sign that's on bottom. So you don't need to know how to derive them. Unless I tell you differently, you don't even have to memorize them, but we just have to know how to apply them and understand what that they can do for us that we couldn't have done last semester. So that's where we're going to put our focus now today. Okay, so back to that question of cosine of 105 degrees. Now again, sometimes just having an estimate is fine. You know, you go to your calculator, you put it in degree mode, and ask it what is the cosine of 105, and that's good enough sometimes. It's approximately equal to negative 0.259 degrees. But sometimes we need to be more accurate with it, especially if we're going to be using this for something else. We don't want to round this answer and then have to use it, and our real answer gets further and further off. So we will take the 105 and we have to split it up into two angles that we know. So one way to do that would be 60 plus 45. That's not the only way to do that. You can split it up into two other angles. Sum or difference, your call. You'd have to say this is like U and this is V. U is just a way to say the first angle and V is a fancy way to say the second angle. So in this first one, I've already plugged in the formula. The formula says take cosine of U times cosine of V, subtract sine of U times sine of V. So I typed it up for you, but usually you have to plug those into the formula. And so we still have to know unit circle. So we're supposed to know sine and cosine values at 60 and 45. So let's go ahead and plug those in. At 60 degrees, cosine is a half. At 45, it's square root of 2 over 2. At 60 degrees, sine is square root of 3 over 2. And at 45 degrees, it's square root of 2 over 2. So it's often a good idea on these question types to slow down and double check your work here. I just applied the unit circle 4 times. So even one mistake out of those 4 is going to mess up the rest of my work. Okay, and then we just need to simplify this. So multiplying fractions, you just multiply the numerators together to get your numerator, multiply your denominators together to get your denominator. Minus, do the same thing over here. Square root of 3 times square root of 2 is square root of 6. And 2 times 2 is 4. And they've already got a common denominator, so why not push them together? So it turns out the exact value of cosine of 105 degrees is the square root of 2 minus the square root of 6 all over 4. Now, if I type this in to my calculator, we should have an idea of what it's going to be, right? It should be the same thing as this. True? If I'm just comparing decimals. And so I typed that in, saw that those decimals are equivalent, which means that I'm in good shape. Easy way to check. Didn't use the formula wrong, didn't use the unit circle wrong, didn't make an arithmetic mistake. I doubt we'd let you use a calculator on this quiz, but if you did have a calculator, you need to do that. So just to be clear, if you do this on the quiz, if the quiz asks what's the cosine of 105, and you just give this, that's not going to be worth any points. The directions are going to say find the exact value. Okay, that's a skill we tested last semester. This is what we're trying to do today. Okay, any questions from the first example? Okay, then let's do the sine of 15 degrees. 15 is not one that we have memorized on the unit circle. So I'm going to put it in my calculator real quick to see that it's approximately 0.259. Now again, that's not what I'm looking for here. I'm looking for exact. So how could we take 2 angles from the unit circle and then either add or subtract them to get to 15?
Five minus 30.
45 minus 30 is probably going to be the most popular one. There's probably others too, though. Okay, so we're going to call this guy U and this guy V. First angle is U, second angle is V, just to make it match up with the formula. You look at the formula and apply it. The formula says take sine of U times cosine of V. Keep the sign the same. Then do sine of V times the cosine of U. Okay? So I'm not doing any thinking here. I'm just plugging in whatever the formula told me to do. Now, if we pick something like 1 degree plus 14 degrees, then I guess I'm stuck because I don't know the sine or cosine of 1 degree or the sine or cosine of 14 degrees. But since we picked 45 and 30, we should be able to apply the unit circle 4 times. The y value at 45, the x value at 30, the y value at 30, and the x value at 45. Always go a little bit slower there and double check so that you don't mess yourself up at the end. Multiply these fractions. Multiply those fractions. Multiplying fractions is easy because you just multiply the numerators to get your numerator and multiply your denominators to get your denominator. No common denominator needed, although I guess they did have a common denominator. And then since these two already have a common denominator, why not go ahead and push them together as one big fraction? So it looks kind of similar to the answer I had on the other page. It's not exactly the same thing. But you will notice that a lot of these look pretty similar. So if we let you have a calculator, on this quiz, then what I would suggest is type this in. Square root of 6 minus square root of 2. Divide all of that by 4. And it better equal the same thing that the approximation did. This as a decimal approximated should be equal to this as a decimal approximated. But this is what we want as an answer. We need exact values. Okay, any questions about that one? Okay, so before we, well, I guess I wanted to show you a proof too. But I want you to try this one. Cosine of 150 degrees. So first, let's decide how could we split that up. It doesn't matter, like as long as you can think of two angles you know from the unit circle that add or subtract to 150, it's not wrong. But just so our work looks a little more the same in case something goes wrong. What is two angles we could add to 150? Okay. So not the only one, but go ahead and do that one. So go ahead and try to throw that in the formula, apply the unit circle 4 times, see what you get, and then we'll see how you did.
Wait, why do you like
Okay, so I'm hoping your answer here looks familiar. Did anybody's answer look familiar to you? Did you see the answer and then feel kind of silly working this question this way? I hope so, because this is really one you're supposed to have memorized, right? 150 is a spot on the unit circle. So I wouldn't recommend this path for this question. I mean, this is more work than you should have to do. You should say, well, the x value at 150 is negative square root of 3 over 2. But to convince you that these formulas work, and you needed to do a practice question anyway, the formula says take the cosine of the first angle times the cosine of the second angle, use the opposite sign, and then do sine of the first, sine of the second, times the sine of the second. So over here, cosine of 90 degrees is 0, which is why I don't even care what that is. The sine of 90 is 1, and the sine of 60 is square root of 3 over 2. So you end up with 0 minus square root of 3 over 2, which of course is negative square root of 3 over 2.
Wait, you said the cosine of 60 degrees is what?
Well, I didn't care because this was 0. 0 times anything is going to be 0. So
Oh.
I just realized it didn't matter. But yes, I mean cosine at 60 is 1/2. Yes, Jay.
Why couldn't you just say just the cosine of 90 minus, or plus the cosine of 60? Why do you have to do cosine of 90 times cosine of 60 minus the sine of 90 minus?
Well, see, this is a function. So this is like cosine of all of this stuff. So it doesn't really work like distributive property. It sounds like you're trying to distribute this cosine, but cosine's not like a constant or a variable. It's a function. So I mean, you can try it, and it may even work on this question, but it would just be a coincidence. For every one time it works, there's going to be 20 times where it doesn't work. So, okay, and just for your own sake, because it's really not that much of a stretch here, of some of the identities we did last semester, some of those were called cofunctions. So we talked about sine and cosine being cofunctions, and this was just something that you needed to memorize a couple times last semester. One of your least helpful identities, but still one that we asked you to do. Well, if I needed to, I could now prove this to you, because this is just a different sign, and it says take the sine of the first times the cosine of the second. Doesn't have to be a number, I'll just call it theta, keep it theta. This is minus this one. And then, oops, sine of the second times the cosine of the first. So I could throw those two angles into the formula. One of them's a number, one of them's just a variable. But then the sine at pi over 2 is 1, and the cosine at pi over 2 is 0. So you end up with 1 times cosine, 0 times anything is 0. And so just to show you that if you know those formulas and you plug them in, it makes some trait proofs pretty easily, work out pretty easy. It all comes together pretty fast. Okay, so let's practice some more of this, and that will be a separate handout, please. So those of you at home can download it if you want to. Those of you in class, you just write it on a separate sheet of paper. Sorry, I thought I had it printed out, but there's not much that you're missing out on, because you can see about half the first page is just those 3 things written there. So I'll give you a minute to get that out. So on this handout, yeah, we're really just kind of practicing some of the same stuff, but we're showing you some different variations. So this is the practice I'm going to do with you. You'll get similar type of practice in the bookwork. I'll put the agenda back up at the end of the screen. You'll see that I'm asking you to do 5 of those book questions for homework. Have those done before you come back. But these are the question types that we think you should be able to do. So be able to find the exact values of sine or cosine or tangent of something, whether it's in radians or degrees.